Um, all right, so let's start off with our triangle. All right, guys, let's calm down, please. All right, so we're going to start off with the first type of problem is the right triangle. And all these problems will be with right triangles, all right? Or determining if it's a right triangle or not. So let's start off with 6, 8, and x. And we're trying to solve for x given the other two sides. So again, this one is using Pythagorean theorem. Okay? Yes, Sam. Thank you. Yeah, these are going to be your example problems for your review. All right, so Pythagorean theorem. Remember, we always have to identify the A and the B and the C, or the two legs, and the hypotenuse. So which one are the two legs on this? Tristan? 6 and 8. So this one is going to be my A. The 8 is going to be my B. So that means the hypotenuse is x, which is my C. Right? So to use Pythagorean theorem, you always have to have at least two sides. And you're trying to solve for the third side. That makes sense? One of the key things is keeping the Pythagorean theorem type problems separated from the trig function problems that we're going to be looking at. All right? So Pythagorean theorem, you always have to know what do you need to use Pythagorean theorem? At least, do you need all three of them? No, you need just two of them, right? And you're trying to find the third one. So what would my equation look like once I plug it in? So 6 squared plus 8 squared is equal to x squared. All right? Okay. So once we get our equation written, our numbers filled in, what do we do first? So we go ahead and square everything that we can. So 6 squared is 36. 8 squared is 64. We can't really square the x yet because we don't have an actual number there, so we just bring down our x squared. So now we add those two together. So we get 100 is equal to x squared. And then our last step, we always have to get rid of this squared. Right? So we square root both sides. And we get x is equal to 10. All right, so that's kind of your basic Pythagorean theorem problem. It's fairly straightforward to where you're given your two legs. Any questions on this one? Okay. So let's move on to the next type of problem. So still with Pythagorean theorem. So I'm going to kind of spin this one around a little bit. Just because we don't want to get complacent with triangles always being kind of positioned or turned the same direction. So the right triangle could be flipped or turned any direction. And if you need to go back to the first one, we'll come back to it at the end. Just draw this line straight across. And again, it doesn't have to, if you're drawing these, it doesn't have to be perfect. Just kind of draw it close. Make sure your right angle kind of resembles a right angle. Okay? So now let's do 15, 9, and x. Yes. What's that? 15. 15. Yeah, so this bottom side is 15. This side, the shorter side, is 9. And then this top left side is x. All right, so what information am I given in this problem? Ziad?
You give it A plus 1. No, wait. Let me picture. A, no, B and C.
So B and C?
Yeah.
Okay.
I had to turn my head sideways because it's like before or something, so take a selfie.
You're going to need to? Okay. All right, so which one of those three is the C? 15? All right. And then A and B? Which one is A? 9 or X? Doesn't really matter, does it? So your A and B, they're both legs, so it doesn't really matter which is which. So which one do you guys want to put as A? I heard X first, so let's go with A for X. Again, it doesn't matter because whenever you set them up, since your A and B are both positive and on the same side, doesn't matter which one goes first. All right, so then 9 is B. So for this one, what's my equation going to look like? What's my equation going to look like?
A, B squared plus B squared equals C.
All right, but let's go ahead and...
X plus 9, X squared plus 9 squared equals
All right, so what's different about this problem and the first example we did? Right, this one we already know C, right? And we're solving for one of the legs. So can we square the X? No, not really, because we don't have a number there to multiply times itself. And then 9 squared is 81. 13 squared, or 15 squared, sorry. 5. What do I need to do next? Subtract the 81. So that's going to cancel out here. I get x squared equal to 144. All right, does everyone follow what we've done so far? As again, these are examples. That's what's going to be on the quiz. It's basically this, the same thing backwards. Well, you can't use this on the quiz. You use this to study with. And then what's my last step? Square root, because I've got it, again, got to get rid of that squared, right? So we get x is equal to 12. Okay? So that's our second type of Pythagorean theorem problem, where it's really the same basic setup. You just have to be aware of which side you're solving for, or which side's missing. Okay? Any questions on that one? Everyone good? If you have questions, ask now. Yes, Sam. Oh, yeah. Okay. So there's one more type of Pythagorean theorem problem. Oh, you know what? Don't put the little red square on this one. So just the triangle itself without the 90-degree angle mark. All right. So what? Thank you. It sure is. All right, so for this Pythagorean theorem problem, we're not solving for a side. We're already given the A, B, and C, or we're given three sides. For this one, what we're going to do is, well, let's determine if this is a right triangle or not. Okay? We don't know what kind of triangle it is up front. We know the three sides, so we're going to use Pythagorean theorem to check to see if it is a right triangle. Okay? So does anybody remember how we set these up? What we do with these? All right, so one person. All right, Jerson, what do we do with these three numbers? All right, so again, what we're doing with this one is checking to see, is it right? Okay, so we're checking to see, is this a right triangle? So we still use Pythagorean theorem, because if it's a right triangle, then Pythagorean theorem will apply to these three numbers, to where a squared plus b squared should equal c squared. All right? But on this one, since we're not sure if it does or not, I get the feeling you guys aren't really paying attention. But if you're like talking and on your phone and stuff and not fully focused, you're not going to learn it. All right, so with this one, since we're not sure if it's a right triangle or not, We put the little question mark above our equal sign because that's what we're checking is that left side of our equation actually equal to the right side or is it not equal? All right, so we go ahead and square everything. So what is 15 squared? 225 and 22 squared? 484. And then this one I honestly don't know. 729. All right, so since we have all three numbers, we can go ahead and square all three numbers. And now we just simply add the a squared plus the b squared. What is it, 709? $709. Okay. So 709, is that equal to 729? And no, it's not equal, right? So what does that tell me since those two are not equal? It's not a right triangle. Yes. Yeah, so right here, since it's not a right triangle, we still haven't determined what kind of triangle it is. All right, we eliminated it being a right triangle. So now what we're going to do is check acute or obtuse. Okay? So is it acute or is it obtuse? So here what we kind of the consistent way to determine this is compare c squared to a squared plus b squared. All right, so for this part, I always try to stay consistent. And I look at how does c squared compare to a squared plus b squared? Is it more than or is it less than? So you look at your I'll just do this. So look at this side here. How does that compare to this side? It's bigger. Okay, so c squared is bigger than a squared plus b squared. So which one of these two words means bigger or larger? Obtuse. So this one is going to be obtuse because this is greater than. Because c squared is greater than a squared plus b squared. Okay? And again, that's how you can stay consistent with these and not, because it's easy to get confused on, the greater than, the less than thing. But if you always start with your c squared, compare it to your a squared plus b squared. And just determine, is c squared greater than, is this side greater than the left, or is the right side greater or less than the left? All right? Does that make sense? I'm going to do this. All right, so that is all of them with Pythagorean theorem. All the different types